The unit of moles can be used to connect the other units in chemistry. So for example, if I want to find the mass of a helium atom, well, we just read the molar mass from a periodic table, which is in grams per mole, and then we multiply this by moles per atom to cancel out the mole. And 1 mole is 6.022 by 10 to the 23 atoms in this context using Avogadro's number. And similarly, given the mass of a proton in atomic mass units, which is in grams per mole, you can find the mass of the proton in a similar way, but in this context, we refer to a particle rather than an atom. And similarly, if we're given a mass of a substance that's produced in a chemical reaction, then we can convert this to a number of moles. So we have the mass in grams over the molar mass in grams per mole, which you can calculate for nitric oxide from the periodic table by adding the molar masses together. And in this context, we can find a percent composition of calcium and chlorine in calcium chloride. So here you'll calculate the molar mass of this compound using the periodic table, then calculate the molar mass of calcium and the molar mass of chlorine, and then divide them by the total molar mass. So for example, you'll have the molar mass of chlorine, and you'll divide that by the molar mass of calcium chloride, and multiply by 100%. And you can find the concentration of a solute dissolved in a solvent. So for example, salt dissolving in water, which will be in moles of solute per liter of solvent. And a number of moles also appears in the ideal gas equation, which we can use to solve for the pressure, volume, and so on.